Now, what happens during stretching? In exercise physiology, we talked about the anatomy of a muscle fiber. In that, we focused on a sarcomere, and that a line of sarcomeres makes up a myofilament, which makes up a muscle fiber. Now, in those, we have cross bridges, and a contraction meant that there was a change in the actin myosin, where there was a sliding that happened. Now, the reverse happens in the stretch, so you're talking about a lengthening of the sarcomere. And maximum flexibility is when every sarcomere that makes up that myofibril, every one, is stretched out, meeting its maximum length, and that is where you have reached flexibility. After that point, you start going into tendons, other structures of the muscle itself. Now, you can go through a stretch without stretching every single part of the muscle fiber, but like I said, a true full stretch will incorporate every sarcomere in the stretch. Now, during a stretch, we have what are called proprioceptors, and proprioceptors are linked with our nervous system that send feedback to our brain to let us know what the muscle is experiencing. Those proprioceptors help us decide when we need to stop. Sometimes the proprioceptors are telling us, ouch, wow, you better stop now, or some of them could be sending relaxing messages where the muscle is being stretched out, toxins being squeezed out. Now, the proprioceptors, there's several different kinds, and before I go on, what proprioception is an impulse of where the body is in its own position and movement. So it's a sensory feedback. Now, within our muscle, the muscle fibers, you have two different kinds of fibers, intrafusal and extrafusal. Now, your extrafusal fibers are the actual muscle fibers, what we talk about as muscle fibers, where the sarcomere is, where the contraction's happening. Now, intrafusal fibers are also called muscle spindles. They run parallel, and that's where our stretch receptors are. That's where those primary proprioceptors are that send us the feedback about the stretch reflex. Extrafusal fibers will lengthen, and as those are lengthening, so are intrafusals. When they contract, there's tension on the tendons and the Golgi tendon, or at the point where the Golgi tendon organ is located. Now, that Golgi tendon organ is sensitive to the change in tension and the rate of tension, and based on the feedback that it gets, it will send a message to the brain relaying that there's tension at the tendon and that the stretch needs to be stopped, because the tendon is not something that is stretchy. And so that is telling you that you need to stop before there is damage done to something that is not a muscle fiber. All right, what's happening during a stretch? We have a myostatic or the stretch reflex. So what that stretch reflex does is cause a muscle contraction in response to an increased muscle length. So you're stretching, going too fast, it catches you and stops you, causes that muscle to contract so that you don't push yourself too far. In reverse, the Golgi tendon reflex, the muscle relaxation and lengthening is a response to tension. So you have muscle tension that's increasing during a contraction or passive stretching. Then the Golgi tendon organs, they're activated, they send impulses and adjust the muscle tension. As this is going on, then you're also looking at contracting muscles that are inhibited and antagonistic muscles that are activated. So you're looking at the reverse reaction. This is called a reciprocal activation. When this happens, the contracting muscle relaxes as its antagonist is activated. So what all in a nutshell, what the Golgi tendon organ does is to help prevent tearing of muscles and tendons. It's sending a response back saying, whoa, wait a second, okay, we're okay. Moving on. The lengthening reaction. When muscles contract, they produce tension, and at that point, that tension is where the muscle is connected to the tendon. So when this tension exceeds a certain point, it triggers something called a lengthening reaction. Now the lengthening reaction actually inhibits the muscles from contracting and causes them to relax. So this works in conjunction with the Golgi tendon. It's powerful enough to overcome the movement, send a signal to the muscle spindles telling them to stop.